Once upon a time, there was a king who wanted to have a circular garden. So he called one of his gardeners and explained him the layout of the garden which he wanted to have. So one portion of the garden, which is the red portion, will be for roses, and the other portion, which is the green portion, will be for animal grazing. Now the green portion will make an angle 60° at the center of this circular garden. Also, the diameter of the circular garden would be 42 meters. Now, the king wanted to fence the region demarcated for grazing of animals. Why? Because he did not want the animals to move to the area where there are roses and eat up all the roses, nor he wanted them to leave the garden and go away. So, he wanted to fence the entire grazing region. So, he asked the gardener, what will be the length of the fence required for the grazing portion? So, let us mark the points. Let us mark this point as O, A, and B. So, we have marked these points. Now, what is the length of the fence required? The length of the fence is the length of this region, that is AO, plus the length of this, which is BO, plus the length of this arc AB. We know that this field or this garden is a circular garden. So this part of the garden between these 2 points A and B is an arc. So we want the length of this arc AB. So the length of the fence required is AO plus OB plus AB. Now the gardener sees that AO, since O is the center, AO is the radius of this garden. He already knows the diameter, which is 42 meters. So the radius will be half of the diameter, that is half of 42, which is 21. Again, OB is also a radius of this garden. So OB is also 21 meters plus the length of the arc AB. So what we get is 42 plus the length of the arc AB. So the length of the fence required is 42 plus length of arc AB. Now the gardener does not know the length of the arc, but he was a smart gardener. He observed something. What did he observe? He observed that as the central angle, that is the angle subtended by an arc at the center of the circle, as the central angle of an arc increases, the length of the arc also increases. So in this case, we see that if theta 1 increases to theta 2, the length of the arc also increases from L1 to L2. So as the central angle increases, the length of the arc increases. He also observed a few more things. When the central angle theta is 180°, we know that we get a semicircle, that is half of a circle. So when the central angle is 180°, the arc length will be half of the total length of the circle. We know that the total length of the circle is circumference. So when the central angle is 180°, the arc length will be half into circumference. Now half can be written as 180 divided by 360, and we know that circumference is 2 pi r, where r is the radius. So arc length is 180 by 360 into 2 pi r. Here 180 is the central angle. So we can write it as theta by 360 into 2 pi r. Now if the central angle theta is 90 degree, we get a quadrant, that is we get 1/4 of a circle. The arc length will also be 1/4 of the total length of the circle, which is equal to 1/4 into circumference. Now this 1/4 can be written as 90 divided by 360, and circumference is 2 pi r. So the arc length in this case is 90 by 360 into 2 pi r. Again we can replace 90 by theta because theta is the central angle. So theta by 360 into 2 pi r. This is what we have. Now if we consider the entire circle, even this can be considered as an arc with a central angle theta equal to 360 degree. In this case, what is the arc length? The arc length is obviously the total length of the circle or the circumference. This can be written as 360 by 360, which is 1 into circumference, which is 2 pi r. So 360 by 360 into 2 pi r. Now 360 is the central angle. So we can write this as theta by 360 into 2 pi r. So in each of the cases, we saw that the length of the arc is given by theta by 360 into 2 pi r. So it is theta divided by 360 into the circumference of the circle. Here 360 is constant, 2 is constant, pi is constant, and for a given circle r is constant. So as theta, that is the central angle, increases, the arc length will also increase. Now coming back to our question, now can we find the length of this arc AB? Well, the radius of the circle is given as 21 meters. The central angle is given as 60 degree. So find the length of the arc AB. Well, the length of an arc is given as theta by 360 into 2 pi r. What is theta here? The central angle. It is equal to 60 divided by 360 into 2. Let us take pi to be 22 by 7. And r, which is the radius, is 21 meters. So 60 by 360 is 6, 1 by 6. 7 and 21 get cancelled. 2 and 6. So what we are left with is 22. So we get 22. So the length of the arc is given by 22 meters. Now what is the length of the fence? The length of the fence is 42 plus length of the arc AB, which we have now calculated to be 22 meters. So this is equal to 64 meters. So the total length of the fence required is 64 meters. So the length of an arc of a circle is given by theta by 360 into 2 pi r, where theta is the angle subtended at the center by the arc and r is the radius of the circle. Now what about this arc? This is the major arc of the circle. How do we find the arc length? Well, if this angle is theta, this angle will be 360 degree minus theta. So the length of this arc is given as 360 minus theta divided by 360 into 2 pi r. So again, central angle by 360 into 2 pi r. So this is how you find the length of the arc of a circle.